So today we're starting a new chapter and we're moving from graphing and looking at one linear equation to looking at a system of linear equations. And today you're going to learn how to solve a system of linear equations by graphing them. So we started with this activity. Your family starts a bed and breakfast. It spends $500 fixing up a bedroom to rent. The cost for food and utilities is $10 per night. Your family charges $60 per night to rent the bedroom. So it asks you to write an equation that represents the cost by using this. So C equals 10 times X plus 500. And then an equation that represents the revenue or the income they earn from renting out the room. And so that is R equals 60 times X. And then it wanted you to just write them together because it's a system of linear equations. And a system of linear equations is just a set of two or more. But for now, we'll only be looking at two linear equations. And so then you could use these linear equations to figure out their cost after a certain number of nights, X, and their revenue after a certain number of nights, X. And after you made the table, they wanted you to go back and figure out how many nights your family needs to rent the bedroom before they break even. And their break-even point is the point when the cost is equal to the revenue, which they've explained up here. And that is 10 nights, cost of 600, revenue of 600. And so after 10 nights, they are actually making a profit every additional night that they rent this room, barring any other major repairs or cost in keeping up the room. Then they asked you to graph the system, and we talked about how you didn't need to graph every single point, especially when the y-axis was counting by 50s. You wanted to pick numbers that were compatible with the chosen axis given to you. So we graphed the y-intercepts of both the cost and the revenue equations, and then we scanned and we looked for multiples of 50. So for cost at 5 nights, cost of 550, and then at 10 nights a cost of 600. And then we did the same thing with the revenue. We graphed the y-intercept at 0, and then at 5 nights it was at 300 because that was our first multiple of 50, and then at 10 nights it was at 600. And when you connect them, the point of intersection is at 10, 600, and it represents the point that the two equations are equal to one another. And how does it compare to the break-even point? It's the same, that at 10 nights they have spent a total cost of $600 on the room, but they've also earned a total cost of $600. So then that brought us into the vocabulary terms for this lesson. Again, a system of linear equations is a set of two or more linear equations, and then the solution of a system of linear equations, they got quite wordy, but really it's an ordered pair that represents the point at which the two equations are equal to one another, and it's usually referred to as the point of intersection. So we had these steps for solving right now. You graph each equation in the same coordinate plane. It says estimate the point of intersection, especially if it doesn't occur exactly on intersection point of the grid paper. And then check the point by substituting X and seeing if you get the same Y value. And so that's what they've done here. And you don't really need to make a table because you know how to graph equations in the form y equals mx plus b from their slope and their intercept, which is what they've done here. But I think this example is more powerful because we did this one in class. So the slope is -5, the y-intercept is 14, and we chatted about how you have to make the scale fit and you don't want it to be super big, so counting by 2 here works just nicely. So 14, and then this says down 5 over 1, but it's not counting down 5, it's counting down 5 along my y and then going over 1. Down 5 over 1, down 5 over 1. And then y, the slope, the slope is 1. The y-intercept is -10, so -10. And then it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, because we're counting by 2. So going up 1 is really going up half of the grid space. And then the solution then is the point where they intersect at 4 and -6. And I can test this by putting in 4 for each of these equations, and I should get an answer of -6. Which I did. So I know I've graphed them right and I've picked the right solution point. This one is a little bit simpler. The numbers are smaller. You graph them, and so a y-intercept of 0 and a slope of 1, so up 1 over 1, and reverse down 1, back 1, down 1, back 1. And I did the same thing for this one because if I just started here and went out into quadrant 1, they would have never intersected. So I had to go backwards and do the opposite of the slope to continue these graphs, and the solution here is -1, -1. And if you plug that in, you would see that you would get the same y value if you put in -1 for x for each of these. So that's just a quick recap graph using the slope and y-intercept to make sure you're got the correct scale and you're graphing the correct points, and you should always find a nice solution for today's work.